A very good morning to all of you. I welcome you all for this engineering thermodynamics course. The today's classroom discussion topic is dual cycle working principle and to derive the air standard efficiency and mean effective pressure of the dual cycle. The motivation of the today's topic is it is important to know the working principle of the dual cycle, and the outcome of the today's lecture is so you should be able to calculate air standard efficiency and mean effective pressure of a dual cycle after completion of the today's class. Now, the dual combustion cycle, it is also known as the limited pressure cycle or the mixed cycle because it is a combination of the petrol and the diesel engine. So that is, it is a combination of Otto cycle and diesel cycle. So because in the Otto cycle, the heat addition is taking place according to the constant value, and in the diesel cycle, the heat addition is taking place according to the constant pressure. So in the dual cycle, so here the heat is added partly at constant volume process and remaining half of the part according to the constant pressure process. So now how can we plot the PV diagram and the TS diagram of the dual cycle? So 1 to 2, it is isentropic compression process, and 2 to 3, it is a constant volume heat addition. That is, half of the portion is according to the constant volume, and 3 to 4, the remaining half of the volume, that is according to the constant pressure heat addition process, and 4 to 5, it is isentropic expansion process in the expansion stroke, and 5 to 1, it is a constant volume heat rejection process. And similarly, it is a representation of the dual cycle on the TS diagram. So in the Otto cycle, we come across with the compression ratio, and in the diesel cycle, we are having the compression ratio as well as the cutoff ratio. And here we are able to get the expansion ratio also, we are able to get it in terms of the dual cycle. So if you want to derive the efficiency of the dual cycle, so the formula will remain same, the work done by the heat supplied. So work done formula also will remain same, that is the heat supplied minus heat rejected. But here the heat is supplied partly according to the constant value, so that is the CV into T3 minus T2, and the remaining half of the portion according to the constant pressure, so Cp into T4 minus T3. So heat rejected always will take place according to the constant value process only. So here the heat supplied is nothing but constant value plus constant pressure. So like that, there is a little bit modification to the previous diesel cycle and Otto cycle because it is a mixing. So that's why the name is given as the dual. That is the heat addition. Some part is constant value and some part is according to constant pressure. So that's why the name is given as the dual cycle. So here we are able to derive, that is just you go on substituting this particular the equation just to find out the temperature values, that is the T1, T2, T3, T4, T5 values, and substitute here. So we are able to get the dual cycle efficiency is equivalent to this particular the 13.10 equation. That is, up to this 1 minus 1 by r to the power of gamma minus 1, it is basically resembling like Otto cycle efficiency. Now it is the extra portion we are multiplied to this Otto cycle efficiency, that is beta into rho to the power of gamma minus 1 by beta minus 1 plus beta into gamma into rho minus 1. So that is the air standard efficiency of the dual cycle. And similarly, how can we find out the work? And the mean effective pressure value is nothing but is the work done divided by the swept volume. The swept volume is nothing but V1 minus V2. So whenever we are substituting the work done equation and similarly the V1 minus V2, so that is this can be written in terms of the compression ratio because V1 by V2 is nothing but the compression ratio. So the V1 minus V2 can be written as V1 into R minus 1 by R, so that the 13.12 equation will give you the mean effective pressure. So in the today's class, we discussed about the dual cycle representation on the PV diagram and on the TS diagram, and why it is called as a dual cycle, because the heat addition is a very important one. So partly according to constant value and constant pressure, and we derive the air standard efficiency and mean effective pressure of the dual cycle. So in the next class, we will solve some problems on the dual cycle. So thank you one and all for listening this lecture on the dual cycle. Thank you.